Sorghum originated from Africa. Africans know how to plant, cook and eat it. It is processed into a very wide variety of attractive and nutritious traditional foods such as semi-leavened bread, couscous, dumplings and fermented and non-fermented porridges. Sorghum has been referred to as grain of the 21st century Africa. The potential for sorghum to be the driver of economic development in Africa is enormous. Continuing focused fundamental and applied research is essential to unleash sorghum's capacity to be the cornerstone of food security in Africa. In terms of tonnage, sorghum is Africa's second most important cereal. The continent produces about 20 million tons of sorghum per annum, about one-third of the world crop. Nigeria is the largest sorghum producer in West Africa, accounting for about 71% of the total regional sorghum output. Nigeria's sorghum production also accounted for 35% of the African production in 2007. The country is the third largest world producer after the United States and India. However, 90% of sorghum produced by the United States and India are destined for animal feed, making Nigeria the world's leading country for food-grain sorghum production. In the northern part of Nigeria, sorghum is consumed by mostly women and children 3 times in a day. This makes them deficient in some essential nutrients like vitamins and minerals needed for their daily existence. To reduce incidences of malnutrition, especially among women and children, scientists in Nigeria are developing nutritionally high sorghum varieties at the Institute for Agricultural Research (ABU) Zaria to address malnutrition, especially among children in northern Nigeria. Professor Mary Yeye is the project investigator of the Africa Biofortified Sorghum (ABS) in Nigeria.
We all know that zinc and iron is problematic, and we have is documented by World Health Organization, the number of people that are deficient and particularly vulnerable to these women, pregnant women and children. And we know the position of sorghum in our system. Quite a number of people depend on sorghum for their feeding, especially people from the entire northern part of the country. And many of them are resource poor. They cannot afford animal protein and vitamins and mineral sources. So it was conceived that if these essential minerals could be inbuilt into the major food which they eat, it will improve the health of the population.
The goal of the research-based technology component of the ABS project is to develop a transgenic sorghum that contains increased levels of essential nutrients, especially lysine, vitamin A, iron and zinc.
The objective is that we have sorghum that is rich in vitamin A, iron and zinc. Iron deficiency, it leads to anemia, and anemia, if it's prolonged for long, it can lead to impairment. And then also zinc and vitamin A for blindness. So working with DuPont, there was sorghum modified or transformed transgenically, which is added with zinc, iron and vitamin A. And so these are delivered to us. Initially 5 countries were participating in the project, but because of the funding, right now is only Kenya and Nigeria that are involved in the project. And the objective is to integrate these materials into our local materials. And in Nigeria, sorghum is grown in 3 different ecologies. We have the Guinea, we have the Sudan, and we have the Sahel. So different sorghums are adapted to this region. So our intention is to pick at least 1 variety of sorghum adapted to these ecological zones and then integrate the materials we got from DuPont. The first material we got was called ABS 188, and this one is with increased vitamin A, iron and zinc. and then we try to integrate them into the 3 varieties selected for Nigeria. By integration, we cross. The first product that you have is called F1, and then the F1 you make subsequent crosses to the material to have backcross, backcross 1, backcross 2, backcross 3. The intention is to go as far as to backcross 5 or 6. And in genetics or breeding, the essence of backcrossing is to stabilize the material. Also maintain the genetic background of the material. Before then, you can start maybe what you call the yield trial.
The nutrition-enhanced sorghum will be used by the product development team for integration of the nutritional traits into high-yielding African and farmer-preferred varieties.
If at least if we make a success with 2 or 3, we have made a good leap, because we know the number of people that are suffering from blindness or threatened with blindness is more. But that is not the end. You know, after the vitamin A is stabilized, then next will be zinc, to follow another zinc and iron, then protein. You may ask me why protein? Protein, for instance, it has been found that in sorghum, when you cook, the digestibility is reduced. So the intention, the overall objective of this goal is to make sure that there is no indigestion when sorghum is cooked, and also to enrich it with vitamin A. And it's good news to tell you that what we have, the event that we are working with now, which is not even the last, the vitamin A content is greater than what was achieved in golden rice. So I think we are making progress. This is just at experimental stage, or will I call it research. The product of research is to deliver to farmers, and that is our aim. And thank God we have the biosafety law in place, which will enable us to do multi-locational trials on farm. Then after that is to go for subsequent release, and then the material will be in the hands of the farmers.
With the introduction of biofortified sorghum, the high cases of malnutrition and hidden hunger will be addressed.